Hi, Professor. This is Deepthi. This video is a small brief on assignment 4. We've installed or imported all the necessary libraries and the classifiers here required for the assignment 4. And coming to the pandas, we're reading the data using read underscore CSV and using the head function, which gives the data of the first 5 or 6 columns of the data frame. And here to get the statistical description, we are using a function called dot describe. It gives information on count, mean, standard deviation, minimum first quartile, second quartile, and third quartile, and max of the given columns in the data frame. And here we're identifying the null in the data in the given columns using a null function, and sum gives the sum of the null values in each of the columns. And you could see calories has 5 null values, and to replace those null values to the mean, we need to initially identify the mean value using a dot mean function, and then using dot fill na, we are replacing the na with the mean values, and the data is shown here. In the next question, using a pulse, 2 columns called pulse and max pulse, to find out the aggregate functions of minimum, max, count, and mean, and printing the same. Here is the output. In the fifth question, to find filtering of the data to select the rows with the calories between 500 and 1000, and hence we are using condition greater than 500 and less than 1000. We could see the data, the same data here, which is greater than 500 and less than 1000 for the condition. And in sixth question, it's the similar, but then the condition has been changed. The pulse should be less than 100, and calorie value should be greater than 500. And here is the output, wherein the pulse is less than 100, and for the same data, for the same row, we could see the calories greater than 500 are filtered. And here's the output. And seventh question, we are creating a new data frame, modified data frame that contains only duration, pulse, and calories columns. Hence, we are dropping the max pulse column. Axis equal to 1 represents the column. Hence, we are dropping max pulse column using a dot drop function. And here's the output. And to delete the max pulse from the main data frame, we are calling the main data frame here df, and using the same function dot drop function, axis equal to 1 column, and here's the data frame without the max pulse column. And ninth question, we're changing the data type of calories to int, so using as type int, and hence you could see the data types of all the columns and the calories as int 32. For the 10th question, we used plot.scatter with x and y axis, which gives us the plotter function, which gives us the scatter plotted output as shown here. For the Titanic data set, we're calling the train function as mentioned using read underscore CSV, using the head function to get the initial 5 columns of the data frames. And here we are trying to find the correlation between survival, that's a target column, and sex. So select the sex and survived column from the main data frame, and grouping the data by the sex column, and find the mean of the survived columns. And this sort function is used to which sorts the data frame by the survived and in descending order, as ascending is mentioned as false. The correlation between survived and the sex indicates how a passenger genders and chance of survivals are related. As per the historic perspective, the majority of the males were on the ship than females. Hence, it is important to keep the sex column as a feature because it provides the valuable information for predicting the target column, which is survival against the sex. If you can see, the female survival rate is 0.74 and the male survival rate is 0.1, which is very less than compared to female. And here, this is just the correlation rate minus 0.54. We used a label encoder function from the preprocessor module, which is to encode or transform the categorical value of sex as a two numerical values. And the fit transforms is a method in the label encoder which classes that fits the encoder values of class and transforms in numerical format. And we used a correlation function here to find the correlation, which is, and the result is a negative correlation. And this is the matrix of the correlation between each of the columns. And here comes the visualizations of the data frames, the survival of the survivals again, sex again. Here creating two separate plots for each of the values of the survived columns using the face grid from the Seaborn library and the g.map um, functions. It's basically a function that maps the historical plot type of MATLAB to each of the subset of the data in the face grid and plots a distribution of the sex. And the histogram of the sex column for the survived and for the not survived and survived indicates relation between sex and the survival. Is the this is a CMAP which generates a correlation matrix for the columns in the trained data frame dataset. And the green background gradient makes it easier to visually identify the correlations. Here's the heat map visualization. Again, using a heat map function from the Seaborn library, creating a color encoded matrix of the plot in a rectangular data. And the mat here gives the matrix of the data that will be plotted as colors, and annotated through gives the annotate the cells of the grid with their respective values. Vmin and Vmax set the maximum and minimum values for the color scale, and the center sets the values at which the color scale should be centered. CMAP sets the color map, and VLAP of color map has been used to plot the heat map here. To naive Bayes classifier, we did with the train and test data using read underscore CSV, and creates a new column called train and sets 1 and 0 values for train and test to distinguish when they combine in a single data frame. And these are the input features, and this is the output that contains an output. And the DF data frame is now filtered with features target and train. The sets and embarked are now filtered or now transformed to numerical values using a replace function. And training a test and train and test data frames are created using are used for training and testing. And here we are dropping any rows with null values and extracting the survival data from the column train, and using train underscore test underscore split to use to split the train data into training X train Y train and test X test and Y test, and specify the proportion or the size of the test data as 20%. And here we're using the naive Bayes classifier. Naive Bayes classifier gives we're using a classifier called Gaussian NB, which gives a creates an instance of the Gaussian naive Bayes classifier. Fit has been used to train the classifier on X train, Y train, and predict function is used to predict the X test data and stores the data in the Y prediction. Classification reports generate summary of the prediction made by classifier, which include precision, recall, F1 score, and support. And confusion matrix gives the summary on the number of true positives, false positive, true negative, and false negative as shown. And the accuracy underscore score is the accuracy of the classifier by comparing predicted values, predicted value by pred with the true values by test. We can see the accuracy as 0.76. And coming to the class data, we're reading class data using read underscore CSV. This is the CMAP as shown earlier, and using test underscore train underscore split data here to train or to get the to split the train data into training X test, X train, and Y train, test as X test and Y test as mentioned earlier. And here we're using the Gaussian NB classifier similar, and using the fit, predict, and classification report and confusion matrix and accuracy score functions as mentioned to get the precision recall FN score support. And the accuracy rate is here here its accuracy rate of the naive base is 0.46. And similarly, we're using for SVM method, we're using a classifier called linear SVC. That's the only difference, and the rest of the functions that are used are the same, like fit, predict, classification report, condition report, and accuracy. And here the accuracy is calculated as 0.4, which is less compared to the naive base. Here we could see two visualizations of the glass data set. The first one is the histogram, and the last one and the next one is the bar plot. Here we use it. We use it phase grid from the Seaborn earlier as mentioned earlier. The business price is 20 here, and these are the attributes of the bar plot with row as type and column as BA with the height 2.2 and aspect 1.6. We have the two visualizations shown. And Gaussian naive Bayes algorithm always mostly gives a better accuracy than other algorithms. Thank